field of view. A total of more than 35,000 labeled images are available for training and testing. So the purpose of choosing IPAC dataset is its larger amount of labeled fundus images for 5 DI stages as shown here in the table. Okay, here you can see that this dataset includes almost 25,000 images for stage 0, almost 2,500 images for stage 1, 5,200 images for stage 2, almost 900 images for stage 3, and 700 images for stage 4. So these numbers clearly show the class imbalance of images. Data augmentation techniques are utilized to remove class imbalance data problem because this problem could adversely affect model accuracy. So for data augmentation, geometric, photometric, and GAN are widely used techniques to do so. Photometric techniques tend to alter useful color-based features of VR signs, whereas GAN is computationally complex. That is why geometric augmentation techniques are found to be more suitable for this application. We use translation, rotation, and rescaling for geometric augmentation of our data. Now, the balanced IPAC data is split into 3 sets: training, validation, and testing. The split ratio we use is 70-20-10 for training, validation, and testing respectively. This system is also very important to prevent the model from overfitting and to assess how well the model is generalizing. So our next step is data pre-processing. This step is performed to enhance visual details such as shapes, colors, and edges of the image. Sharper images with enhanced features allow a better understanding of useful retinal features for learning. Therefore, we use a few image processing techniques in the proposed framework. First technique that we use is brightness adjustment. It plays a very important role in visualizing feature details. If images are too dark or too bright, then retinal features cannot be detected properly and necessary information can be lost. So original IPAC dataset contains images of varying brightness. We, after very careful analysis and several experiments, found that the brightness level between 0.5 to 1 is most optimal, whereas 0.1 to 0.5 is too dark, and greater than 1 is too bright for feature visualization. So we have selected brightness from 0.6 to 1 as an optimal brightness for all of our images. Next image pre-processing technique is image resizing. So again, original images available in IPAC datasets are with variable size. We resize all of them to a fixed size of 224 by 224 pixels. And third image pre-processing technique that we deployed is image normalization. Image normalization is performed to alter the range of pixels intensity by enhancing different retinal features on the same scale. This image normalization also helps to speed up the gradient descent functions of model by avoiding extra iterations. Okay, so now this step involves choosing deep learning AI algorithm for our work. To get effective results on prediction, the model must be trained on a large amount of data, which is often unavailable. So we adapted the transfer learning approach in which the deep learning architectures has already pre-trained on a very large number of datasets that can be used further for the desired classification. So in our work, we have implemented 5 pre-trained models, which are further customized by adding few neural network layers and then trained again on IPAC datasets. So those 5 AI algorithms were Mobile Net V2, Mobile Net V3, NestNet Mobile, Efficient Net V2 V0, and Inception V3. Among all of them, after extensive experimentations and analysis, we found that Mobile Net V2 was the most optimal model based on its accuracy. So accuracy-wise, its results were higher. And if we talk about number of parameters, so it was the most lightweight model among 5 of them. So a custom mobile net V2 model has been chosen for automated VR screening. The customized model has 2 components, pre-trained network mobile net V2, and along with that, we added few additional layers. These additional layers are global average tuning, flattened layer to dense layers and soft max layer. So this model is again trained on iPad dataset with different hyperparameter configurations. We evaluated the model performance in next step. Although the chosen model was performing well, but its accuracy was further optimized by tuning hyperparameters. In this work, a few hyperparameters that we configure are as follows. Number one is optimizer, number two is learning rate, and number three is batch size. So if we talk about optimizer, an optimizer is basically a function that modifies the attributes of neural network, such as its weights and learning rate. Thus, it helps in reducing overall loss and improving accuracy. Adaptive moment estimation, ADAM, stochastic gradient descent, SDG, and root mean square propagation, RNS-top optimizers are evaluated. And ADAM was found to be most suitable optimizer among all. So next is learning weight that defines the adjustment in the weights of our network with respect to the loss gradient descent. It determines how fast or slow we can move towards the optimal weights. Third hyperparameter is batch size, which is another important hyperparameter that controls number of sample images for the network for our training iteration. The batch size controls accuracy of error gradient estimation when training neural networks and is very important during training. So these are our results for hyperparameter tuning. Here you can see that we found ADAM as best optimizer, 0.0001 and 64 as optimal learning rate and batch size for this work. Finally, the output of proposed framework is in the form of 5 DR stages. The model is evaluated using different performance metrics which are tabulated here: accuracy, sensitivity, specificity, precision, F1 score, and area under curve. So here you can see that we have attained overall accuracy of 98.4% using the proposed framework. Now, if we compare our proposed framework with other state-of-the-art techniques reported in open literature, we can see that accuracy-wise, our model outperformed other techniques with having accuracy of 98.47%. And at the same time, the size of our model is smallest among all. So in terms of total parameters, we are using only 3.5 million parameters. In terms of model size, it is 14 megabytes. Its size is 14 megabytes, which is the smallest among all. And at the same time, accuracy is highest. Now, let me conclude. In this work, we explored potential of deep learning algorithms for multi-stage DR detection. Effectiveness of 5 DL models was analyzed through rigorous experimentation, and we found that MobileNet V2 is the most optimal model. Accuracy of proposed framework is similar to previously proposed dense DL models, yet it is 40 times better accuracy size ratio. It has better accuracy size ratio. Now, all these features make it very suitable to operate on edge devices in remote locations where cloud connectivity is intermittent. Model generalization by using different approaches such as cross-validation and hybrid databases are few future directions. These are the references that we use. Thank you so much for your time.
Two our talks are recorded, and then we will proceed.
Good morning. Assalamu alaikum. My name is Dr. Ida Shahzad, and I am a research associate at Shahzad Eye Hospital, Karachi. And today I'm going to be talking to you all about a special interest of mine, which is artificial intelligence in healthcare. And we will be covering the top 5 biases in machine learning or artificial intelligence studies in healthcare. Now, a bit of a background first. Artificial intelligence in general is in no way new to the world, but in the field of healthcare, it is a relatively novel introduction. So as time increases, the research going on, the exploration of artificial intelligence in the field of healthcare keeps increasing at a rapid rate. And this is due to advances in technology, advances in computational power. So, for example, in this whole presentation, I will be using the example of diabetic retinopathy screening using artificial intelligence. So, just to clarify that, this is the Topcon NW400, and an artificially intelligent algorithm has been FDA approved to be integrated into this machine for the screening of diabetic retinopathy. So this shows us that this field of AI in healthcare and screening is gaining normality. Now, as I mentioned, special emphasis is given to screening in this, and this is in no way just pertaining to ophthalmology or DR screening. This is being carried out in various fields such as oncology and breast cancer, for example, and in many other fields of medicine. However, we have seen that even though it keeps increasing and there are heaps and heaps of research going on in this field, proper methodology is not followed and it is not being developed with the same rate as the development of technology. So this is one thing to keep in mind when you are studying or when you are going through studies related to AI in healthcare. Right, and because proper methodology is not followed, then these studies are very susceptible, very prone to different kinds of bias. Now, in just layman terms, what is a bias? A bias is any restricting factor or any confounding factor that can kind of alter or distort your results of any study, and therefore it can distort the conclusions that one makes from those studies. So, of course, we all know that all forms of bias must be avoided in any study, or else the results or the conclusions become questionable. Now, looking at RCTs, randomized control trials in AI, you can see that there has been an exponential increase as the time goes by. So in the year of 2021, there were a whopping 26 RCTs carried out in the field of artificial intelligence in healthcare. So we can see again that this is proof that this is slowly gaining normality and it keeps rising as the time goes by. Okay, now how I speak about this with so much authority is because we recently published a systematic review in BMJ Open where we looked at the quality of reporting of randomized control trials of artificial intelligence in healthcare. And in short, we looked at how well or how poorly these RCTs and artificial intelligence were reported, and how they followed certain guidelines of reporting. The one guideline that we used to see the reporting quality was the Consort AI guideline, and through that we made certain assessments of how these RCTs are carried out. In our systematic review, we found that RCTs were from various geographical locations, including China, United States, United Kingdom, etc., and they spanned a number of specialties, including cardiology, gastroenterology, and even ophthalmology. So we have compiled 5 top biases that we found in these studies as a whole, and we have explored how these biases went about in all these studies. So the first bias that we came across that was very prevalent was poor quality input data. Now, what exactly is input data? In order to develop an AI algorithm or an AI system, I have to feed it input data, which is the information that it will use to train itself in order to give certain predictions. Okay, very, very briefly explained. So this is just the basic raw data that I will give to the system. For example, if I am developing an AI algorithm which will help me to screen for diabetic retinopathy, I will give it multiple images in like a high number, like thousands of images of different grade and different levels of diabetic retinopathy, all graded, all annotated, so that the system can study these images and then it can train itself to give the diagnosis or the grades of diabetic retinopathy if it were to be given a blank fundus photo of a diabetic patient, for example. Okay, so again, it is added to the system to train the model to make certain predictions. And in my example, those predictions would be the detection or diagnosis of diabetic retinopathy and its grade. Okay, so as we can assume, as we can expect, high quality input data with accurate data labeling is required to adequately train an AI system. So if I were to feed images of diabetic retinopathy to an AI system with improper grading, with faulty classes and grades of diabetic retinopathy, then that system would learn incorrect diagnosis, and it would give us wrong predictions about if DR is present or absent and what grade it is. So as a revision, the basic, very basic diagram would be, I would give an input to the AI system and it would learn and it would train itself to give us certain outputs, which would be the predictions. Okay, so poor quality or insufficient data can result in poor models making poor predictions, as I just explained to you. And then if that happens, then the model is not generalizable. It won't be generalizable to different grades, different sets of diabetic retinopathy in different settings, in different populations, etc. So this was one thing that we saw that a lot of studies missed out on. Another thing that studies missed out on was telling us how poor quality input data is handled. Okay, so in any scenario, if you are developing an AI algorithm, it is not possible that every bit of input data that you have is perfect. For example, some images will be of substandard quality, will have artifacts, for example. So we as researchers, as developers, need to inform the readers how this poor quality input data was handled and assessed. And this needs to be reported in our paper. So this is what we found, that a lot of authors did not report how the poor quality input data was handled and assessed in their study, in their trial. Now, coming on to bias number 2. This was the inclusion and exclusion criteria of input data. Now, what this means is that when I am developing an AI system, I will, kind of outline the kind of populations that I have used in that trial. So this must be properly defined, like what kinds of populations were used or what kinds of populations were left out of the trial. For example, in diabetic retinopathy, we want to see what our inclusion criteria is, what the age was, what the gender was, what the ethnicity was of our inclusion criteria. So this must be properly defined, because they will inform the reader about what populations were used to train the AI models. Okay, and then in extension, this will determine which groups of population this particular AI system can be utilized in real life settings. So, for example, if I have used population X to train my algorithm, then the reader will know that, okay, this algorithm is applicable in population X, but it might not be applicable in population Y or population Z. So this is very important for us to kind of clarify to the reader. So again, the example that I gave, what gender, what age, what ethnicity did we use, if we use type 1 or type 2 diabetics in our program. So similarly, in exclusion, what patients did we exclude from our study? If the patient had any other known retinal pathology, for example, if they had vein occlusion, or if they had any prior laser treatment for diabetic retinopathy or any other pathology itself. So are those the kind of patients that we excluded from our study? So this must be very, very clear. So, and if this information is missed, this can result in under or overestimation of algorithm performance in different groups. And the reader might think that okay, this algorithm can be used in this population and not that population. So this can result in over and underestimation. Right. The third is the AI algorithm version. Now, as expected, when AI algorithms are being developed, they undergo multiple updates and multiple, you know, improvements. So the findings that are achieved in a particular trial are only applicable to the specific version used in that trial. For example, a very, very basic example, as we know, the iPhone that we use and that we love has undergone multiple updates over the past 2 decades. The iPhone that I have today in my hand is not the same as the one that we had, back in 2010 or 2011. So if I see that a study is done using a particular older version of the iPhone, right? So that iPhone has a different camera, has a different software system, and that cannot be applied to the iPhone that was released, for example, 5 years later. So we need to clarify which version of the algorithm and which technology is used. Okay. Many AI studies leave out this information, and that leaves the reader confused about the applicability of other versions of the algorithm. So if the reader were to assume that, okay, if I want to use the same system in a newer iPhone, would it work? Would it have the same results? So that would lead to a lot of confusion. So this was another thing that was missed in a number of studies. Okay, coming on to bias number. Unspecified trial protocol. Now, a protocol, nowadays, a lot of trials publish their protocols, and that is so that the readers can know specifically what steps were taken in the method to carry out this trial and to reach the results that are stated. So they must be available so that it can be assessed and replicated. So trial protocols must also be given so that the process can be replicated in future studies. Okay, so when the protocol is not available, so then the information is missing on the processes that are followed to generate the conclusions of the trial. Okay, so if I read a trial and I don't know what the steps were to carry out that trial, then I might question the results that and the conclusions that are given for that trial. So I need to know. The reader needs to know, and the author. It is the author's responsibility to clearly state how this trial was followed. As I mentioned, this will lead to low replicability of the trial, and then its usefulness in future studies can be questionable. So a lot of AI studies did not report trials adequately. Coming on to the last and we saw, there were unidentified harms and stopping guidelines. Now, any given intervention, any given trial is not without its risk, right? And in any given trial, the potential harm, potential risk must be outlined so that the reader can know what exactly the level of safety is of that particular trial. Right, so here you have it, either if it's going to be a low risk or a medium risk or a high risk trial, or the intervention is of various risk levels. And then as an extension, stopping guidelines need to be established and recorded. For example, if I'm giving an intervention, then if that intervention, for example, has a particular kind of allergy, then I will define stopping guidelines. That if this adverse event is met, then this intervention needs to be stopped at this point. So that is a stopping guideline. And then, so for for that reason, this must be very clearly established. So in many AI trials, we saw that harms and stopping guidelines were not identified, and this would again misinform the reader about how safe or unsafe a trial is. the trial might, appear falsely safer than it really is, and that is just very misinforming and kind of misleading to the reader. Right, so those were the top 5 biases that we encountered in AI studies in healthcare, and that makes us wonder, and that makes us, kind of be aware for future studies to look out for these particular biases so that we can kind of assess how useful or how applicable a particular trial is to our setting. Okay, thank you so much for listening to me, and if you have any questions, then feel free to contact me. And thank you, and Allah Hafiz.
Right, thank you very much. If you have any questions regarding the first two talks, you can ask me after my talk. Next speaker is going to be Dr. Ijaz Sheikh. He's done some good work on diabetic retinopathy related to artificial intelligence. He's developed some applications working from the UK. He's kindly agreed on a short notice to give a talk, so I would like to welcome Dr. Ijaz Sheikh.
Thank you, Professor Rahman, for inviting me to talk about utility of smartphone-based artificial intelligence approaches for diabetic retinopathy. Basically, this project was done by Dr. Adil Sheikh as part of his Masters in Public Health at London School of Hygiene and Tropical Medicine. And I gave him input, and we involved other colleagues in ophthalmology to help them look at the literature, what are the inclusion criteria, what should be done, and they produced a very good paper. It took them about a year to go through the whole thing, and I would just like to share what is there. I won't go into technicalities of the equations which were produced, because we had input from different people, research analysts, and it's not easy. It's time consuming, but at least we are moving in a direction which will help us develop our own system in Pakistan. We know diabetic retinopathy is increasing. There's a lot of issues, and how we can manage these people, because early detection and timely treatment, and also the appropriate follow-up is the situation we need to tackle. It's a huge burden. And main thing is this: we have screening programs in different countries, but there's high false positive. And in my clinics, if I see like 8 diabetic retinopathy patients, 4 of them will have just maybe simple exudate or a query about it. So the main thing is how we detect basically diabetic retinopathy, and most importantly, referable diabetic retinopathy, the people who would need treatment. Later on, I am presenting about a predictive model who will identify these people. That project has been approved by National Institute of Health Research in London, UK, and my colleague Sajjad Haider, who did his PhD after retiring as a consultant ophthalmologist, and Salman Sadiq has done some papers that I think I'm doing it in the next at Shalimar C. So please do visit there. So there's so many classification systems, but it's also important we use something very simple. The main thing is what are our screening needs and what are treatment indicated. So if any imaging system which we are utilizing simply based on cameras, smartphones, they should be able to tell us what it is and which people should be indicated for treatment. And we know diabetic macular edema and proliferative diabetic retinopathy are the two main things. And I believe Professor Rahman is using these levels of grading for his projects. So maybe it can be married together with what I feel is really good. So looking at the meta-analysis, this is level 1 evidence. It is saying a systematic review, and I will go through how the papers were identified through literature search that had met base and EM base from 1974 till March 2020, and they found 23 papers, and then duplicates were removed. They screened about 22 papers. Sorry, it's a very busy slide, but there were only 4 full text articles who were assessed for eligibility in this meta-analysis. So these were the studies included, and all of them came from India actually. They have been using the video camera with smartphone, and in fact I have tried that. I bought it. It came just before COVID. We used that camera, but unfortunately the sample size was so small we couldn't make any definitive paper on that. But I hope it can be improved on that. We know how the artificial intelligence is working in screening programs for everything, for heart, skin, wherever. But the main thing is a black box theory, because the scientists, they don't want to know about these things, but the computer scientists, they know what it is, and they will just go through different criteria and they will come up, what is the classification, what is the proliferative diabetic retinopathy. So previous presenters have very nicely looked at the systems and what are the biases and how they can be eliminated. So moving forward, these were the 4 papers that were selected, and they show the type of cameras they were using. Actually, they were all same. They were cross-sectional. These numbers, sample size was reasonable, 213, and this one is 900, is quite good. And mainly they used software which was based on Medios technology, Singapore, and one was based on IRM. Classification system was really good, and then study quality was based on QuadS model. So they looked at the diagnostic accuracy of smartphone-based artificial intelligence approaches for diabetic retinopathy, and they were showing very good results. More than 80% is really good, and they were almost 90% for specificity and its sensitivity. So this is a hard, sorry, again, I think it's slightly out of focus because I just completed it this morning. I was up till 2 o'clock with friends who needed to catch up. Anyway, so this is the hierarchy of summary receiver operating characteristics. Main thing was to how to specify the diabetic retinopathy, how we can diagnose firstly. And this is a very good model and showing good area here. And then they look at the forest plot for referable diabetic retinopathy, because this is what we need to identify. This is the key, otherwise we will be spending a lot of resources on just picking up the things which may not be relevant. So again, the specificity and sensitivity is shown up here, and it is for the referable diabetic retinopathy. And they look at the biases in more detail, and all these studies, they showed very low bias because they had picked up very specific areas which should have been included. That's why out of 23, only 4 were identified to meet all the eligibility criteria based on smartphone-based artificial intelligence. The main thing was the cameras, which can give you instant information instead of going retrospectively. Because the lack of facilities, a lack of trained personnel who can identify. You sit on the camera, they will tell you this patient has referable diabetic retinopathy, and you move on. So I had this experience about 7 years ago. It was done at initially Al Habib Eye Hospital on Sheikhupura Road with Professor. So we use the old system that's handheld indirect ophthalmoscope, a camera on the other side. So I did a workshop there, and we had some images. And Professor Zarbert was like helpful, and other people, they got trained. But again, I think it was lack of resources and the time was not helpful to move forward. So this was one thing we did in February 2020, just before the COVID struck. So use the video camera. My colleague Rosina, she's actually finishing her PhD in artificial intelligence at King's College London. So she's very keen. She has a charity hospital in the name of her father, who was my colleague, ophthalmologist in UK. So she's very keen to develop these things. And I hope she'll be a very useful person to contact in the future. I think she's working with iArt at the moment. So eventually, later on, I tried to develop Medan camera based on artificial intelligence. We had all the apps developed, how it could be loaded, and then we were looking at the prediction models for classification, what we could do annotations. But they're going, these are different phases. It was done like 2 years ago. Every year there are 10, 15 projects coming through, randomized control trials are coming. More and more will be done. But main thing is, because in Pakistan we have targeted approach now, where people who are working in big institutions, like Professor Rahman told me, he's working with NED University to develop the programs. Well done, and any support will be helpful. And for my part, I just mentioned I've taken retirement from NHS just to make sure I'm more available to do all these things. Because this is what I want to do. I'm not a research scientist, but I think I may develop things over a period of time and keep learning. With my colleague Sajjad, he retired as a consultant ophthalmologist. Then he started doing his PhD. He's diabetic himself. And he has done very, very good papers. And he's encouraging everybody, especially our team in BPOS, please do. If I can do it, you can do it. So what we need to look forward is to get started, quit talking, and just move forward. Because unless we do it, we won't be able to tell people, okay, if 4 studies have come from India, we can produce 6 in due course of time. Thank you very much.
Sajjad is the one who was in Shifa?
Shifa, yeah. Sajjad Haidar. Sajjad Haidar. He's a very dedicated person.
We have been together. I was in Navy in Islamabad in 1997, 8, 9.
Yeah, at that time he moved back to UK. Because he was the one actually, he invited me to join medical retina at Bristol Eye Hospital, where he was a fellow at that time. He was approaching like 58, I was 50 when we did fellowships there. And the consultants were amazed, what are you doing? We want to become consultant. We want to prove that we can deliver. It's been 13 years since. I'm getting younger. I think I'm more enthusiastic than ever before because I know there's a team, the work is being done. I had a thought process. But if we can materialize, that will be the dream come true. Thank you very much.
Thank you very much, Dr. Ijashi, for this lovely talk. I think it just goes to show that, there's a lot that can be done and that is being done in this area. Now, I'm sort of, in the next 10-15 minutes, I'm going to sort of highlight some interesting points that I think I've gathered over time. And my talk is mostly general talk. What we are going to do is to discuss a couple of things. So here are my disclosures, okay? AI Diagnostics is a company I formed. I'm the CEO of this company to run the projects of artificial intelligence. So the agenda is why should we as ophthalmologists even care? What's in it for us really? Then trying to understand really basics of AI. We can't go in depth, in a short 15 minutes talk. then we also have to understand there's a lot of hype about AI, but what are the limitations of AI? And I think Dr. Rida has already talked about quality of reporting of AI research, so I'm not going to delve into it too much. And then I think I'm going to try and, a couple of slides talk about the deep learning algorithm for diabetic retinopathy screening for mobile devices, taking on from what Dr. Ijaz Sheikh has shown here. So, when a new phone comes in or a new car comes in or a new techniques come in, for example, cataract technique, there'll be people who are early adapters and there are people who will be, mid-level adapters seeing everyone else is doing it and then say, okay, I'll do phaco with this way, I will do LASIK, I will do femto, or I will do smile technique based on, other people's experience. And then there are late adapters who are forced into doing it because everybody is doing it and patient come and ask, Dr. Sahab, aap phaco kar rahe hain? So, right, so there are different ways of adapting technology. I like to think that I'm one of the early adapters. So if I see a technique, I feel it's safe, I feel there's sufficient evidence to use it, then I would like to use it. So when you look at this car, what comes to your mind? Yeah.
Innovation, artificial intelligence.
Yes. So this is a car which is full of technology. Yeah. And they are making a lot of progress. They're working. It's almost like a work in progress. You hear every time that there's some new thing that is there. And the thing is that really, would you like to own or use this car? Would you like to use this technology? So the rise of artificial intelligence has been gradual, but recently because increase in computational power, what computers can do, especially in small devices, and as the cost has becoming much less and less, this has taken a lot of improvement in recent years. But if you go back, I was trained in Glasgow, and somebody has looked at this back in 1994. So visual field interpretation with personal computer-based neural network. At that time, it takes a lot of time to actually run the algorithm. But people were trying those things back in then. Now, to get artificial intelligence into healthcare, I think one of the most important things is to educate healthcare professionals about the utility of artificial intelligence. If I don't if I don't think artificial intelligence is good for my patients, I'm not going to adapt it. So same thing, if I don't think the electronic health record is going to be good, I'm not going to use electronic health record. So these things have to be sold or to the health community. So there's a lot of hype about artificial intelligence, particularly in ophthalmology. So you can see that this is, artificial intelligence is as good as eye doctors. DeepMind, this is a Google company, can detect over 50 eye diseases as accurately as doctor. And this is 2018, 5 years ago, nearly 5 years ago. Yeah. So the thing is that if you look at this image, and most of us have looked at fundus images all our life, can you look at this and tell what is the blood pressure of this patient? Maybe, if the patient has high BP, you can see some diabetic retinopathy changes. You can say, well, maybe, the patient has uncontrolled blood pressure, but you can't tell what blood pressure the patient has. Can you predict the risk of myocardial infarction? It's very difficult. Can you predict the risk of cardiovascular events? Looking at this picture, that is also very difficult. But okay, so Google Calculator can calculate the risks for cardiovascular events, it can calculate the risk for myocardial infarction and can tell you, predict that, what are the possibilities or probability of you having this problem. And this is the paper that was published based on only retinal photographs by deep learning. Okay, so that was one step. How about telling age? I mean, we've been looking at, images. So let's say if they're drusen, you can tell the patient is, probably middle-aged, right? But what if there are no drusen? It's a normal fundus image. Okay, here it is. So the deep learning has looked at the images and has predicted age. And you can see that the actual age here is 57 and the predicted age is 59. So that's not bad. And you can see the graph, it's very, very close all along. Okay, next step. How about gender? Can you look at the fundus image and tell it's a male or a female patient? As an ophthalmologist, we can flip a coin and say, well, 50% chance this is male, 50% chance it's female. And this is the deep learning model. So the prediction is 97%. It can predict what the gender is. So the ophthalmology has been always on the forefront of artificial intelligence. Okay, and I think As an ophthalmologist, we don't realize this because, as Dr. Jashik has pointed out, we are not connected with our engineering colleague, and especially in Pakistan, we're not connected to what is happening in this domain. But the first autonomous AI model that was approved in the USA by FDA was ophthalmology for diabetic retinopathy screening, IDX DR, that Dr. Ida was talking about, which is connected to the Topcon fundus camera NW400. And so the patient goes there, get their eye scan, leave the office. They don't see a doctor, they don't see a nurse, nothing. They get a report that they have diabetic retinopathy or not, come back in 6 months or see a doctor, whatever the grade is. So it's completely autonomous system. And as I think Dr. Ida has pointed out already, the literature in artificial intelligence is just skyrocketing. It's getting exponential. So when we published our paper when we were doing our paper in 2020, we had only this studies. So once our paper was approved, they asked us to update the search. They said, okay, it's all good, just update the search, make sure it's up to date because the whole process has taken a while. We went and updated the search, so there were 26 extra studies, more than the original publication. So this was amazing. So here are some really basic concepts to sort of go home with. Okay, artificial intelligence or deep learning is the algorithm that are trying to simulate human intelligence. The way our mind works. So the big box is the artificial intelligence, and then there's a process of machine learning where what we do is we give annotated images to the machine. So we say this is microaneurysm, this is cotton wool spot, this is exudate, and then the machine, based on those features, extract the output and says that this is diabetic retinopathy, class this or that. But the reason artificial intelligence has taken off recently is the deep learning. So the deep learning, you don't have to tell the machine where the microaneurysms are. Because if you do, I have done that work, it's extremely laborious, time consuming and boring. But if you label the image, if you look at a retinal image fundus, they say this is diabetic retinopathy, this is not diabetic retinopathy, this is grade 1, grade 2, as Dr. Jasek has pointed out, we use ICDR classification. And if you just label the image, don't extract features and just throw those images to the deep learning model extract those features that we think are important, and a lot of time it extracts features that we are not even aware of. For example, the way it's detecting age and gender, what are the features it's looking at? We don't know. And that's the black box. But the advantage of deep learning is that you just have to give a label to the image that this is a dog or a cat or a horse, car or a plane, and it extracts features and it learns. So these are the input layer, and then you have hidden layers, and then there's output diabetic retinopathy, yes, no, as Dr. Ijaz has already shown. And this is the difference between machine learning and deep learning. In machine learning, there is a human person who is doing feature extraction, which is very time consuming, and that's why it can sometimes delay the takeoff of artificial intelligence projects. Okay, and you really have to sit down and annotate. This is one of the images that I was annotating. And you can look, where do you stop annotating a single image? It's very time consuming because, there are different features, and if you identify one microorganism, do you identify the other microorganism? What do you do? And this is a labeled image. So I haven't done anything here. I just labeled grade 4 diabetic retinopathy. So this is then I just go to the next image and the next image. And this is just another way of looking at these things. This is a chest X-ray, and deep learning and machine learning. Another way, same point, emphasize that the difference between machine learning, there is a feature extraction element which is absent in deep learning. And with the deep learning, it is data hungry. And I think this point we will come back to it because you need to give it lots and lots of data. So for example, you're teaching the machine learning model to differentiate between a cat and dog. You have to give a variety of cat and dog images. So you can't just give 10 images here, 10 images here, because then it will not learn. And I think some of you who are using iPhone, and maybe these features are there in the other window or Android phone, the iPhone also recognizes, it sort of sorts your photo library by recognizing images of people. So you can tell this is me, this is mom, this is dad, this is wife, and children and friends. Yeah. The thing is that the more images you give to the iPhone, the more accurately it recognizes people. So the same thing, same way it works here. Okay, so the work that is being done in artificial intelligence, mostly it's diagnostic work at the moment. There's prediction for treatment and clinical laboratories is not happening, but most of the work is diagnostic imaging. So how the model is developed. Okay, so once you have a data set, so you've got data set of cats or dogs, you have to divide it into three sections. One is the training section, and one is the tuning section, and then internal validation. And then you take the data to the images that the model has never seen. The problem is a lot of the studies publish what they have. So if you have features of diabetic retinopathy, features of no diabetic retinopathy, they would look at those images and then they train and then they validate the database on itself without doing external validation. And if you don't do external validation, you don't know how good your database is, because sometimes database learn features which we are unaware of. Okay, and one example is that somebody looked at the pneumonia prediction from chest X-ray, and the doctor's accuracy was about 80%. The model accuracy was about 97%, and they were surprised how the model was able to identify. Yeah, and then they went back and tried to hide areas on the chest X-ray to find out which area of the chest X-ray it was focusing on more, and it turned out that the model was not looking at the chest X-ray at all. It was looking at the label at the top where it says portable. So the portable chest X-rays that was done on the ward because patient was so unwell to go to the X-ray lab were the ones which patients are more likely to have pneumonia. So instead of picking features from the chest X-ray, it was picking features from the labeling right at the top where it says portable. So it's very important to then take that model and actually examine on patients outside. I think all of us know this 4x4 model of sensitivity and specificity. In particular, the artificial intelligence in retina. So if you have something that you're thinking about macular degeneration or diabetic retinopathy, you really have to develop a database, okay? And you have to curate high quality images so that the model can learn from this. You have to classify them. Then the data has to be visualized. So at the moment, I think Dr. Saab has worked and I have worked in this area. The most time consuming thing that happens is actually labeling data. यहाँ पे हमारे साथ डॉक्टर अरशद भी बैठे हैं. He's also involved in data labeling, and it's very time consuming. And then once you have this data, then you split the data into training, validation, and test sets, and then you do model training. Then you get a model, and then you take the model to the community and do external validation. And if it shows good results, good generalizability, then you do model deployment. And this is just showing the graph that the most time-consuming part of the project is data. And if you go and talk to the engineering colleague, they are just saying that there's no facilitation and cooperation from medical doctors, because the engineering guys can build a model, but they can't get the data. We have the data, and we are not interested. Most of us are not. So when I went to NED University, they was actually surprised that somebody is actually coming to them with the data, and they were like, red carpet and come and join us and this and that. Right, so coming to application of AI in ophthalmology. Okay, so the first thing that you have to realize that 2/3 of the ophthalmologists in the world, they live only in 17 countries. Okay, and most of them are practicing in big urban centers like Dubai, London, these areas. Even in some of the US counties, there are not enough ophthalmologists, because the number of ophthalmologists is very high in US, but they're also all working in San Francisco, New York, Chicago, and big areas. So we need some sort of access to the community. And I think we all know that ophthalmology is by nature a technology-driven field. So you go around, you look at the microscopes, you look at the biometry, you look at the OCT scan. All these are actually technology-driven field. So I think it's a natural thing that we will adapt, and maybe adapting this new technology will become a democratizing force for our patient to access health. I don't know how many of you actually know Eric Topol. Eric Topol is like a big scientist in US, and he's published a lot in nature journals and all. And what he's pointed out, that people think radiology is the area where AI will take off, but it's actually ophthalmology, not radiology. And this was the time when one of the FDA-approved devices for diabetic retinopathy was rolled out in the market. again, this is a paper on which basis the FDA approved. So there are two now. I think now there may be three, but until last year there were two. One is the IDX DR, and the other one is INUC or iArt. That are both FDA approved devices for diabetic retinopathy screening. Now, so after all the rosy picture of AI, what are the challenges and limitation of AI, and particularly what are the challenges of limitation of AI in Pakistan? So you can see most of the work that is being done in ophthalmology is focused in diabetic retinopathy over the years. Okay, so diabetic retinopathy is a field that is ripe where we can work. The first challenge that comes in is the challenge of disagreement. Okay, so this is a picture of ROP. And you know, if you ask the experts, and these are all people who are actually dealing with ROP in real life, and you ask them with the image on your right, whether this patient has a plus disease or not, experts, 14% experts say plus, 86% say no plus. But the image on the left, 52% say plus, and 48% say no plus. Now, if you have this kind of data and there's a disagreement on classification, how do you label this data? And if you feed this data into the algorithm will never make correct diagnosis because it's confused. Yeah? So there is this problem. So this problem can be dealt with by a continuous spectrum of disease. So you know, you have patients who have clear-cut advanced ROP or advanced diabetic retinopathy. You have patients who are clear-cut normal. And there are patients in between. So if you look at this graph, something very interesting is being shown here. So these are the experts here. Yeah, so this is one database, this is the other database. There are 8 experts, and what they're doing is they're showing them all these squares are images. So this image, you can see all the experts have labeled it as advanced disease, and the reference standard is advanced. Yeah, and then you move here, come somewhere in the middle. Somebody has said maybe disease, maybe not disease, disease, maybe not disease. And then the average, the reference standard is, maybe. And then you come to this area, and then there is this green and green, okay? And then this is the average color for this image, same thing with the other database. And what we find that there are some people who, some graders who are very confident in their grading, some are over graders, some are under grader. And the problem is with the artificial intelligence, models is you have to input data, and that input data or the reference standard is labeled by humans, okay? And if it's rubbish in, rubbish out. So you put a data which is, very different, which is not accurately labeled. And I think one of the very interesting thing is, if you look at the data sets that are out there on which the artificial intelligence models are being trained, those data sets are labeled by a single person. So, there may be one doctor who has labeled the image, then another doctor comes and labels it. So each image is labeled only once. And that creates a lot of problems because as you can see, this image is yellow here, green here, yellow, red here. So it depends who is labeling the image. They can label the image red or green or yellow or whatever, and then you put that image in the database, and then the database is completely biased and give poor results. But if you have multiple graders who are doing this work, then you get the average out of it, then you get consensus, and you take it from there. So this is one area that is very laborious, and Dr. Arshad is working with other colleagues to actually come up with a data set for the Pakistani population that is labeled by more than one grader. And graders can be anybody, could be medical students, can be doctors, can be ophthalmologists. You have to train them, different ages and experience, but everybody really has to be serious about their job, because and everybody has completed a diabetic retinopathy certification course for grading. This is Dr. Riza's young baby. That's the reason she couldn't come, if she's looking after the baby. And while she's grading images, the baby's joining and maybe giving second opinion. Right, then comes the problem with image quality. Yeah, so some of the images are acceptable, some of the images are possibly acceptable, and some are just poor images. Okay, so what do you do with the images? And I think Dr. Rida was talking about that in the biases as well, that you really have to tell. So if a camera that, I think Dr. Ijaz has made a very valid point, if a camera is taking images but cannot grade 40% of the patient, these 40% patients, because they are ungradable, they cannot be left in the community. All of them will be referred to the hospitalized service. So how good is that camera? And how about a camera that can grade actually 90-95% of the patient? Sensitivity may be slightly lower. Sensitivity may be 95%. So that camera is better than the camera that cannot grade 40% of the images but has the sensitivity of 98%. Because these are all practical aspects of the thing. Then there's a chasm between, artificial intelligence, as I was pointing out. Some of the studies have been published in 2018, 2016, but their implementation is a problem because, deployment, scalability, and what happens that the news channel comes in as soon as you say that I have an artificial intelligence, because that's something they are interested in. They don't know anything more or less. So here is the thing, that this is the implementation gap. So we publish papers, and then fewer patients go blind, once we have implemented. But the gap is the effective innovation has not been tested in real world. So you have a very cool gadget that you go to multiple meetings and present, and you get awards and certificates, and you win a lot of accolade. But when you actually take to the real world, there are problems, because the data has been overfitted in your sample. Okay, or you have trained them on a database of Australian eyes or European eyes, and when you go to your dark funduses, it just doesn't pick up a small microaneurysm. And there are sometimes implementation problems, and there are issues with sustainable environment and all. So this is the valley of death for artificial intelligence. So it's standardization. We've done some work, and the paper that we have published was the consort AI thing. Then we have data privacy issues. So the data that you have in your computer of the patient, can you actually share? Or has the patient consented that their data, even if it is anonymized, can it be shared for training? Do you have to acquire all the data? Is the data biased? Do you have data, for example, in the UK, you have data only of white people, black patients are not included. How about the generalizability issues, differences in machines? So, TopCon image is 45 degrees, another fundus camera is 55 degrees, and another is 35 degrees. Can you actually, build a model on one camera, take it to another camera? What do you do? Medical legal issues and AI biases and ethics, all of them are there. So one of the things is to remember that the AI database sometimes are trained and on well-curated data sets. So the doctors look at everything, the image is perfect, the lighting is perfect, the quality is perfect, okay? But in the real world, this is not what is happening, and that's why there is underperformance of, the first there is hoo-ha for artificial intelligence, but they don't work very well because in real world there's a lot of noise in the data. And one of the reasons that we presented the biases talk initially in machine learning is that if you are building a data set, if you are building a model of artificial intelligence, if you're not aware of those biases, that model will always have problem. And it will actually exacerbate healthcare disparities rather than minimize them. Here is the, a busy slide of publicly available data set. It's not very coming very nicely over there. We don't need to look at anything. The only thing I'm trying to point out, there is no Pakistani data set there. Yeah, so we're talking about diabetes, artificial intelligence, and everything, but there's no Pakistani data set in publicly available data set. Another interesting point now that we are discussing is because of the issues with sharing data, is that if Dr. Saab is working in NHS, I want to look at his images and see, if he has 20,000 images which are well labeled, can I use those images? So if I write to his hospital, it goes to this committee, that committee. It takes 1 year before they come back and say, well, you have to fill another 50 forms to actually make us consider. But now what people are doing, instead of collecting data from this hospital, and this hospital, and then the whole data set is put into the AI model, is I develop an AI model on my data set. I take the model to his hospital, the data remains in his hospital. वहाँ पे आपने जो है वो model को चलाया. Then I take the model to Dr. Ejad's hospital in NHS. Okay? The model is moving around and training on the patient's images rather than the data set, and that provides reassurance to the organizations, to the patient, that their data is not being misused or not being used without their permission. So this is a new concept that is taking place. I think we've already discussed that. We've talked about the biases in the thing. Now, a lot of the time when I go to the meetings, people ask, will doctors be replaced? If artificial intelligence is doing this good, will doctors be replaced? So I think what is happening in early efforts, the artificial intelligence was lagging behind the real humans. Okay, we are in the era where artificial intelligence and humans are close by. So the diagnosis is similar. There will come a time where artificial intelligence will guide us to make decisions, will be more accurate in certain areas. But remember the example of an accountant and a calculator. Yeah. So once the calculator came in, those accountants who adopted the calculator, they worked more efficiently, they were able to see more clients, they were able to do more accurate data calculations. So the calculator is their artificial intelligence. The accountants are still working, they are probably working with more clients now, they are working with more accuracy. So same with the doctors, we will be using artificial intelligence, and none of us will lose jobs, but it will be doctors who are there will be doctors who are artificial intelligence educated, and there'll be doctors who have no education of artificial intelligence. These doctors may be or should worry about their job, because things are changing. You have to adapt as things are changing. And this is really what Steve Jobs said, that the 21st century will be the intersection of biology and technology, and a new era is beginning. I would like to acknowledge my collaborators. Thank you very much. Any questions, discussion, it's open to all.
Yeah, you replied in your last lines. I had a comment that artificial intelligence can never replace a human being because it doesn't have empathy, it doesn't have warmth. A patient can sit in front of it will be a camera like OCT camera. So you sit and it takes the picture and slip comes out, referred, not referred, whatever. So, but it doesn't have a pat, there's no warmth.
Absolutely. And I think what happened in certain areas, because one of the area of research that is happening is patient acceptability. So, you do these tests, you look at the accuracy, but what about patient acceptability? Would patient accept somebody, just doing this and sending them away?
Yeah, because since COVID, things have changed. 2 years ago, started doing webinars on GPOS Forum, and we have done about 15 of them. Now we're back to normalcy. But now the clinics, they are running as virtual. So 40% of the clinics, patients come in, have their photographs taken, pressure checked, every is recorded on the MediSite or electronic patient record. There will be 20 patients, 30 patients. Next day or same day, some ophthalmologists who are fully qualified will look at that, just write to the patient, this is the grading, this is what it is, and if they need treatment, we'll just give them a call, this is what we have decided, are you happy with that, and we'll move on. That means the quality has improved, especially with the Optos machine available as well, because we have wide field images, and patients are accepting it, because they can come on over the weekend. And they're not dependent. You go there, have your people dilated, have all the assessment, and then you're waiting for 2 hours for the consultant to see you.
And then they say Dr. Saab is late because he's operating.
Yeah, but that's a kind of, you say,
the things are changing.
It's a Majburi window, and they are not. The patients are actually not satisfied. Even in America,
actually they are more satisfied. We have done the surveys on that. In a way, they look at the time available. Somebody has to bring them. And then especially AMD patients, and especially I've talked about diabetic patients, because the quality of life is
follow-up patients may be a bit satisfied.
No, even the new ones, all diabetics, all new diabetics, they are seen only once in the clinic. First one, we do optoscan, we do OCT images, and your OCT, find out if there's any ischemia, label it. We know what it is. Next time they have to come, they will be seen by the technician and the nurse. We report on that, and that saves time for everybody, because we have improved the efficiency. It's more cost effective.
I think what Dr. Saab is talking about is I think there are two types of patients in the clinic, and I sort of agree. When we are working in Ahan, so there are two types of patients. One who's come in with a retinal detachment, one who's come in with a problem, unable to see, loss of vision. These patients, they are okay to wait 2-3 hours to see a doctor. But then there's another patient who went to the diabetic clinic. The doctor saw the patient and he said, "Oh, आपकी फंडोस्कोपी नहीं हुई, जाके फंडोस्कोपी कराएं." ठीक है? और कहते हैं यार आते हैं कहते हैं हो जाएगा, हाँ चलें ठीक है ले लेते हैं, वॉक इन पेशेंट ले लिया. Now this guy is sitting there for 2.5 hours to be seen by a doctor saying no retinopathy, come back in 1 year. ठीक है? ये वाले पेशेंट को अगर ये ऑप्शन दिया जाए कि यार देखें आप अपनी फोटोज खिंचवा लें, ठीक है, Dr. Rahman will have a look at it when he has time. You don't have to wait. If there is a problem, he will call you, or he will call you to let you know everything is okay. To my surprise, when I started calling patients back on some of the images that I thought कि यार ये इस तरह का है, I don't get as much thank you in the clinic as I get when I call them कि यार कि देखिए मैंने आपके images देखे हैं, अल्लाह का शुक्र है सब कुछ अच्छा है, आपको I will see you after 1 year, I will see you after 6 years. One of the things that I have noticed, the thank you Dr. Saab is not there in the clinic, because patient in the clinic waited for 2 hours. जब आप उनको अच्छा सब कुछ समझा देते हैं, सब कुछ करके उनको कहते हैं ये सही है, जब जाने से पहले कहते हैं डॉक्टर साहब एक शिकायत है, इतने घंटे बिठा दिया, आँख के प्रॉब्लम से आए थे, कमर का प्रॉब्लम शुरू हो गया. ठीक है, तो आई थिंक जो डॉक्टर एजाज कह रहे हैं कि देयर इज दिस थिंग दैट इज चेंजिंग, एंड वन ऑफ द बेस्ट एडवांटेजेस इज, फॉर एग्जांपल आप क्लिनिक पे नहीं हो, ठीक है, आप यहाँ पे आए हुए मीटिंग अटेंड करने के लिए, आपके जो है वो क्लिनिक खुली हुई है, वहाँ पे पेशेंट आ रहे हैं, इमेजेस करवा के चले गए, एंड जाहिर बात है ये ट्रस्ट विल डेवलप ओवर टाइम, क्योंकि कभी कभी मसला है कि आपने पेशेंट से इमेज तो करवा लिया, फ़ोन कॉल ही नहीं की आपने, या आपने फ़ोन कॉल नहीं की, सेक्रेटरी को बोल दिया भाई फ़ोन कॉल कर दो, ठीक है, या किसी जूनियर स्टाफ को जिसको कुछ पता ही नहीं, वो आपके फॉर एग्जाम्पल आवाज़ सुनना चाहते हैं, इतने पुराने कनेक्शन हुए में जो भी, तो वंस यू डेवलप दैट, ठीक है, अ लॉट ऑफ पेशेंट विल बी हैप्पी, बिकॉज इट्स अ प्रॉब्लम. एंड जाहिर बात है अब आपके शाम का टाइम है, दिन का टाइम है, आप फैमिली के साथ बैठे हुए हो, पेशेंट के इमेजेस हुए, सारे पेशेंट के इमेजेस पहले से हुए, देन यू डिसाइड हु नीड्स टू कम इन अर्ली, हु नीड्स टू कम इन लेट. थोड़ा सा है हमारे एनवायरनमेंट में कि एक्सेप्टेबिलिटी मे बी स्लाइटली लेट, ठीक है, लेकिन आई थिंक थिंग्स आर चेंजिंग.
डॉक्टर साहब एक कमेंट ये करें कि ये हम जो बात कर रहे हैं NHS में सब कर रहे हैं वो तो ठीक है, पाकिस्तान में आपका क्या ख्याल है कि ये कितनी जल्दी अडेप्ट हो सकेगा, उसके लिए डाटा इकट्ठा करना और उसको मतलब
देखें, वन ऑफ द रीजन दैट वी डू दिस काइंड ऑफ सेशंस, I've done it Carop, I've done it other, is actually create awareness कि what is happening, ठीक है, and some other people are already working but they are outside ophthalmology, ठीक है, they are engineers and people who are working in statistical labs and all. मेरा ये ख्याल है कि मैं हमेशा से ये समझता हूँ कि हमारा being slightly disadvantaged in low middle income country also give us an advantage. हम जब यूके में थे तो सबसे पहले जब इंटरनेट आया तो वो टेलीफोन लाइन के थ्रू आया, वो भाई टेलीफोन लाइन, जब यहाँ पे भी टेलीफोन लाइन से चल रहा था, फिर ये हुआ कि यार ब्रॉडबैंड आ रहा है, भाई पूरे यूके में ब्रॉडबैंड बिछेगा. जाहिर बात है पाकिस्तान में ब्रॉडबैंड बिछने का ना इंफ्रास्ट्रक्चर है, ना पैसे हैं, ना कुछ ना क्या, ठीक है. एंड जब मैं 2010 में यूके से वापस आ रहा था तो जब जो है वो इंटरनेट आना शुरू हुआ मोबाइल पे, एंड इट वाज वेरी एक्सपेंसिव. When I came to Pakistan, mobile internet was so cheap. ठीक है, सो अब हमारे पास ये जो एडवांटेजेस हैं, देयर आर सर्टेन एडवांटेज दैट वी हैवंट वेस्टेड अ लॉट ऑफ मनी ऑन द लैंडलाइन मोबाइल, क्योंकि अब जो यूके का जो ब्रॉडबैंड का जो लैंडलाइन इंफ्रास्ट्रक्चर है, एक्सेप्ट फॉर बिग ऑर्गेनाइजेशन, मोस्ट पीपल आर एबल टू यूज जस्ट ऑन देयर मोबाइल एंड डिवाइसेस एंड दे आर हैप्पी. पाकिस्तान में हमने वो सेकेंड वाला स्टेप जो है वो टोटली स्किप कर दिया है, एंड वी हैव जम्प टू द थर्ड वन. We have not invested a lot in 3G and 4G, so maybe we will be able to invest directly on 5G. We don't know, ठीक है. एक और जो सबसे अच्छी चीज़ है कि जो फंडस इमेजेस हैं ये दे आर अवेलेबल टू एवरीबडी, ठीक है. ये कोई इस तरह का नहीं है कि भाई एक फंडस इमेज लेने के लिए आपको दुबई जाके तस्वीर लेनी है या बड़े हॉस्पिटल में है, तो दीज आर इजीली एक्सेसिबल. तो डेटा सेट्स आर आउट देयर. देयर इज दिस अंडरस्टैंडिंग एजुकेशन, देन देयर इज दिस डिजायर टू वर्क इन दिस एरिया. There are engineers sitting here, working on 50,000 salary to develop these models. आपको 50,000 rupees में इंग्लैंड में क्या मिलेगा? कुछ भी नहीं मिलेगा. And some of them are as sharp as anybody. In fact, I didn't talk about it. I have a group that is developing the model, but in parallel, I have another group which is actually developing the camera, a cheaper camera. हमारा जो बिल्कुल आगे का फ्यूचर का प्लान है कि वो जैसे हेल्थ केयर वर्कर होता है, वो ये कैमरा लेके जाएगा घर पे, पेशेंट की तस्वीर ली, ठीक है, तस्वीर में आपको पता चलेगा डायबिटिक रेटिनोपैथी है या नहीं है. पेशेंट को उन्होंने कोई प्रिंट आउट दे दिया, या आप तो आजकल ये कि भाई व्हाट्सएप नंबर पे टक करके रिपोर्ट आपकी फॉरवर्ड कर दी, ठीक है, पेशेंट के पास है, एंड दैट्स इट. पेशेंट को पता है कि मेरे डायबिटिक रेटिनोपैथी घर बैठे हो गया. एंड डॉक्टर जुबैदा हु इज जस्ट लेफ्ट, आई हैड अ मीटिंग विद हर yesterday and we were discussing how to take this camera to, she works in Gilgit Avahan, So the idea is to take this camera to Gilgit, Chitral, where people are living in mountain, aged people who can't visit the hospital, and instead of the doctor, the patient going to the doctor goes to the patient to actually scan. It's not going to be a doctor, it's going to be a technician or technologist who's going to take this camera scan, and this will be loaded through the net. But what we are developing, the first talk was about developing a model that works on mobile without internet.
अच्छा, एक हमने अभी जो डिस्कस किया वो यही किया, डायबिटिक रेटिनोपैथी या फंडस, और इसको अप्लाई क्यों करते हैं?
Glaucoma, ROP screening is a big problem.
Yeah.
And because of time limit, I didn't talk about it a lot, but I just showed you some images and everything. So ROP का क्या है? हमारे पास पेशेंट आते हैं आँख में stage 5, stage 4, stage 5. If these cameras are easily available in not even rural, in the city hospitals, जहाँ पे पेशेंट होते हैं उनको बताते नहीं है, ये सही से वो नहीं करते हैं, भाई शुरू में ड्रॉप डाल के तस्वीर लें, एवरीथिंग इज क्लियर, या तस्वीर लेके हमें लोड कर दें आई क्लाउड पे, वी विल हैव अ लुक एट इट से कि हाँ यार इसको डायबिटिक रेटिनोपैथी इसको रेफर करना है, इसको आरओपी है इसको रेफर करो, इसको नहीं रेफर करो, ठीक है, बिकॉज आई इन माई क्लिनिक आई रियली डोंट वांट टू सी नॉर्मल पेशेंट्स, ठीक है, आई थिंक यू प्रॉब्ली डोंट वांट टू सी नॉर्मल पेशेंट जो आए बस दिखाएं हाँ डॉक्टर साहब क्या हाल है, तो फिर अब होता है कि जैसे जैसे पेशेंट जितना ज़्यादा वेट करता जाता है उसको अगर आप कम टाइम दे दो नाराज़ हो जाता है, तो जैसे जैसे आपकी क्लिनिक के 2-2.5 घंटे आने लगते हैं तो आप बजाय तेज़ी के आपको पेशेंट से थोड़ा और टाइम देना पड़ता है, एंड समटाइम इट्स वेरी एम्बैरेसिंग कि आप देख रहे हैं 75-80 ईयर ओल्ड लेडी हैं जो 2 घंटे से बैठी हुई हैं, आपने उनको देखा और कहा कि यार कुछ भी नहीं है, ये है वो है, ठीक है, तो आई थिंक टू बिकम एफिशिएंट सम ऑफ दिस टास्क विल बी delegated, ठीक है, and then we will work at our time. I mean, when I was in the UK, we used to do diabetic retinopathy grading from home. So these graders, there will be primary grader, secondary grader, then ophthalmologist, and I'll just look at it and say, अपनी मर्जी से कोई टेंशन नहीं है, जल्दी चलेगा, लेट आ गए, कोई इशू नहीं है. So I think some of this work will take off really quick. I think where we as ophthalmologists and as individual, where we position ourselves, ठीक है, आपने डायबिटिक रेटिनोपैथी या आर्टिफिशियल इंटेलिजेंस का जो काम हो रहा है उसमें अपने आप को आप कहाँ देख रहे हैं? Are you going to be somebody who's going to be an early adapter? Are you going to be somebody who's going to develop the model? Are you going to be somebody who's going to use it at the end? तो ये हमें डिसाइड करना है कि where we are.
But again, talk about India because the big country circumstances are similar as ours, and they have programs. The shadows industry, they have their own cameras. They put it on the back of a motorbike, take it to different places, and they do it. Arvind's hospital system, they have huge input. Most of the studies are coming from them, and they're doing everything now. AMD, glaucoma, cornea, even oculoplastics. If you look at it, it's a tumor, BCC or SCC. Just call the patient and do it. Because you can't go to hilly area at 10,000 feet high. So,
and there will be unnecessary delays. You may decide कि भाई 2 महीने बाद clinic है, ठीक है, तो patient will wait for 2 months. And again, for skin dermatology, there are very accurate models. In fact, people have developed apps. So you download that app and you take a skin picture and you take the picture and it tells you the probability of a cancerous lesion is 90%, 95%, or it says 5%, 10%. You don't see a doctor then. But if it's very high, then you go and see a doctor.
I know because my son is in public health as well, and his colleagues, as medical students, they develop apps about asthma, about skin conditions, about arthritis as well.
In UK?
In UK, but it can be made here. The same, if they know what to do. I mean, he's working. I mean, with Arhan, he's been innovative, done a lot of work. And we keep talking about these things, okay, what can be done, how can we improve? Even this one, he phoned me, okay, this article is published by somebody, you know him? I go, yeah, I know him very well, since his birth actually. But things are moving. Unless we don't do it now, we'll be lagging behind, already far behind. Initiative, doesn't matter who else is doing. Just move on, join hands, move on, tell the people. Now we have 5 people here in this room. Next time it will be 50, because we will project that this is the model we have started, this is what we're going to do, and we can deliver. It's not a problem.
No, I think in CAROPT, I think that this is the timing of the course which mostly nobody's around, and I'm getting text from Amir as well if there's no attendance. But when we did the same thing in Karachi, the hall was full.
असल में मैं घर से सोच के आया था कि मैंने ये अटेंड करना है. आई केम ट्वाइस. मैंने वो कोई से देखे, मैं बाहर निकल गया, साथ चला गया, फिर आया, फिर गया. अब वो आपकी भी टॉक खत्म हो रही थी जब मैं एंटर हुआ. मैं क्या को बैठ के देखो शायद कुछ ज़्यादा पता, मतलब इंटरेस्ट डेवलप होगा तो फिर ही आगे चलेगी बात.
रहमान, जो मैं देख रहा हूँ ना,
आई दिख रहा है कि
हमारा जो ब्रेन या आपका ब्रेन या इंडिया का या पाकिस्तान का ब्रेन ना, ये वंडरफुल है, ये एक एसेट है दुनिया में. मैं आपको, द प्रॉब्लम इज विद आवर इंफ्रास्ट्रक्चर. अगर आप ग्लोबली देखें कि हमारा इस वक्त तैयब फट के पता नहीं क्या हुआ.
देखिए वो सब चीजें तो
2-2 करोड़ का तो एक छोटा सा कैमरा है जो अच्छा है.
यस बट नहीं, बट दिस इज द थिंग, ठीक है. सो नहीं देखिए ये, so number one, I totally agree with the first part of your statement, 100%. ठीक है, I think the talent is here, ठीक है. And I have, I have gone to people and talked. People want to do research, they want a little bit of support. ठीक है, आपको थोड़ा सा यार सैलरी चाहिए ना. Nobody's gonna work for free.
और सॉफ्टवेयर इंजीनियर्स इतने हैं पाकिस्तान में कि
बिल्कुल. अच्छा, अब प्रॉब्लम देखिए, हमने जो आपका वाला कंसर्न है, बिकॉज आई डोंट थिंक आई कुड हैव डन दिस फ्रॉम द यूके इफ आई वाज वर्किंग देयर. बिकॉज जैसे आपकी रियलाइजेशन है, वैसे मेरी रियलाइजेशन अब हो गई है कि यार ये 2 करोड़ का हमारे भी वहाँ पे क्या था यार, कैमरा क्लिनिक में पड़े रहते थे, ठीक है. हाँ, यहाँ पे आने के बाद ख्याल है यार ये कैमरा तो हम यूज़ ही नहीं कर सकते. तो हमारा जो ज़्यादा काम है, व्हाट वी हैव डन, वी आर डेवलपिंग द डेटा सेट, ठीक है. एंड इंस्टेड ऑफ मूविंग कि भाई हमारा जो एक्यूरेसी है वो जो टॉपकॉन के कैमरा पे क्या एक्यूरेसी होगी, वी आर मूविंग डायरेक्ट टू मोबाइल कैमरास. तो मेरे पास ऑलरेडी एक कैमरा ब्राज़ील से, एक कैमरा जर्मनी से है, एक डॉक्टर साहब से मैं भी उधार लूँगा वो कैमरा. एंड वी आर यूजिंग डायरेक्ट, वी हैव स्किप्ड दैट 2 करोड़ पार्ट बिकॉज वी लिव इन दिस सोसाइटी, वी वर्क इन दिस सोसाइटी, वी रियलाइज क्या इशूज़ हैं, एंड वी हैव डायरेक्टली स्किप टू मोबाइल. एंड जो डॉक्टर माजदा की टॉक थी, वो जो एल्गोरिदम बना रहे हैं, दैट एल्गोरिदम इज एक्चुअली नॉट फॉर डेस्कटॉप कैमराज, बिकॉज वी अंडरस्टैंड कि दिस इज अ प्रॉब्लम, ठीक है. और वी आर मूविंग डायरेक्ट टू मोबाइल डिवाइसेस विच आर गोइंग टू बी चीपर, ठीक है, एंड विच आर probably more portable and easily implementable. So I think knowing your patients and culture and the country where you work helps in kind of guiding that research area. And the more you go and work there, you realize no one else has worked. And the more you take a dive, there are pearls hiding from sight. So it's been an amazing journey. So I would invite all of you to think about it. Okay, and inshallah when models and things come out, then and participate. Yeah.
Look, I started like 7 years ago, thought of it, got this camera made by 3D. It took about $12 for one. This indirect camera, put 20 diopters in front, mobile back, good quality image. But we have moved forward, so we need to.
When I made my dissertation in 1993, when I did my FCPS Part 2, my topic was proliferative vitreoretinopathy. So I was basically a VI guy. So, and I made all the images with hand. At that time, even the computers were not there. It was electric typewriter and collected again and again and again. And I made diagrams on hard sheets in the dissertation. मेरी भी यहाँ पड़ी होगी थी. हाथ से वो सारी blue line detached point, PVR क्रॉस से ब्लैक से शो किया हुआ, वो है सारी 10-15 केसेस. और उसकी कुछ तस्वीरें उस वक्त क्लोज मेरे पास नहीं था. लेकिन क्या नॉर्मल कैमरा था इलेक्ट्रो 35 उस जमाने में, उसका नीचे लेंस क्लोज फोटोग्राफी के लिए वो मैंने खुद बनाया था अपने हाथ से, गत्ते के अंदर वो करके ना, और फिर साइड पे पहले मैं वो फोकस देखता था कितनी दूर है, फिर वो फुटा रखता था कि कितनी दूर से क्लियर इमेज आएगा, फिर वो देखता. सो दैट वाज द टाइम. वो जो आप इनोवेशन की बात करते हैं वो तो बंदा करता है, एक एज भी होती है, एक टाइम भी होता है, लेकिन
it is not unlimited, sir.
हाँ,
you are biased against.
नहीं मैं वैसे बात कर रहा हूँ. तो नहीं बात नहीं कर रहा. मैं ये कह रहा हूँ कि एक्चुअली हमारी जो कंडीशंस है ना, वो जो एंथुसियाज्म, जो कंट्री का ग्लोबल एनवायरनमेंट है, उसकी वजह से बड़ी डल डाउन हुई है. अगर आप गौर करें, पिछले 2-3 साल से एक मिस्ट और क्लाउड आया हुआ है जिसमें लोग बेचारे कहते हैं कोई जगह मिले तो बात जाए, अच्छे लोग. तो हम उसको किसी तरह फाइट कर लें पहले, और फिर हम अपनी चीज़ों को, हम तो अपने हद तक तो बहुत कुछ कर सकते हैं, बट माशरे के साथ
क्या करना है इसी
वो
माशरे
लड़ना एक अलग इशू है।
So thank you very much. I think there is another session here. Allah Hafiz.
Thank you.